Hey everyone, welcome back. Today, I want to talk about something that sounds incredibly technical, but is actually a problem we all understand. How do you move your entire warehouse without closing up shop for the day? This topic is really personal for me. If you've been following this channel for a while, you might remember way back in episode 69, I shared a war story about a database migration. It was a massive undertaking that forced us to take our entire system offline for half a day. Half a day! In today's world, that's an eternity. Our users were locked out, business stopped, and all we could do was watch the progress bar and pray. This is what we call downtime migration. You shut everything down, move your data, turn it back on, and hope everything still works. It's stressful, risky, and for a growing business, it's just not sustainable. So the big question is, why is it so hard to move your digital warehouse without closing the doors? Why can't we just keep operating while we relocate our data behind the scenes? This is the holy grail of system architecture, zero downtime migration. It's a challenge that every major tech company, from Netflix to Google, has had to solve. Today, we're going to break down exactly how they do it, using a simple metaphor that anyone can grasp. Let's imagine our database as a massive logistics warehouse. It stores all our valuable goods, our data. And the applications that use this data are like a fleet of trucks, constantly coming and going, picking up and dropping off cargo. The paths they take are the read and write paths in our system. Now, we've decided to move to a brand new, state-of-the-art warehouse across town. This is our data migration. The old way, the downtime method, is simple. You put up a big close for moving sign. No trucks are allowed in or out. You then load up all your cargo, drive it over to the new warehouse, unload everything. And once you're sure it's all there, you take down the sign and announce the new address. This works, but as we said, your business is paralyzed during the move. So how do we move while staying open? This is where it gets clever. The process involves a few key steps. First is the initial transport. While the old warehouse is still fully operational, we start copying all the existing cargo over to the new one. This is a massive one-time bulk transfer. Think of it as a huge convoy of trucks moving everything in the middle of the night. This can take hours or even days, but it's fine because our business is still running out of the old warehouse. Customers are being served, orders are being placed, everything is normal. But here's the problem. While we're busy moving the bulk of the data, new cargo is still arriving at the old warehouse. New orders are coming in, users are updating their profiles. If we only do that initial copy, our new warehouse will be out of date the moment we finish. This brings us to the most critical part of the process: dual writes or data synchronization. Once the initial bulk copy is complete, we reroute our fleet of trucks. Now, whenever a truck comes to drop off new cargo, meaning whenever new data is written, it doesn't just go to the old warehouse. It goes to both the old and the new warehouse simultaneously. We are writing to two places at once. This ensures that both our old and new systems are kept perfectly in sync in real time. The new warehouse is no longer falling behind. It's an up-to-the-minute mirror of the old one. During this dual write phase, our applications are still reading data only from the old warehouse. It remains the single source of truth for our customers. The new warehouse is being written to, but we're not relying on it for information just yet. We need to be absolutely sure it's stable and accurate. This phase is all about building confidence. We run tests, we verify data, we compare the inventory in both warehouses to make sure not a single package is missing. Once we are 100% confident that the new warehouse is a perfect, reliable copy and that the dual write process is working flawlessly, we prepare for the final step, the cutover. This is the magic moment. It's like changing the road signs on the highway. We update our system's configuration to tell all the application trucks to start reading from the new warehouse instead of the old one. This switch can happen in an instant. To our users, it's completely invisible. One moment they're fetching data from the old system, and the next, they're fetching it from the new one, with zero interruption. The business never stopped. Now, we're mostly running on the new system. We might keep the dual write process going for a little while, just in case. What if something goes wrong? What if we discover a problem with the new warehouse after the switch? This is where a rollback plan is essential. Because we kept the old warehouse perfectly in sync, switching back is as simple as changing the road signs again. We can revert to the old system in a heartbeat, fix the issue, and try the cutover again later. This safety net is what makes a complex migration manageable. Once we're confident the new system is stable, we can finally stop writing to the old warehouse. We can decommission it and our migration is complete. We've successfully moved our entire operation without a single second of downtime. So let's recap the core insight here. A zero downtime data migration isn't just about moving data from point A to point B. It's about managing consistency. The real challenge is ensuring that while you're operating in two places at once, the data in both locations remains identical. It's about carefully managing the read and write paths of your application so that you can switch from one to the other seamlessly. You start by copying the bulk, then you keep them in sync with dual writes. You verify everything, you perform the cutover, and you have a rollback plan ready. It's a carefully choreographed dance. This concept of maintaining multiple, synchronized copies of your data has profound implications beyond just migration. Think about disaster recovery. What happens if our new warehouse suddenly burns down? If we only have one copy of our ledger, our business is gone. But if we have been maintaining a synchronized copy in another location, another city, even we can switch over to the backup warehouse. Our fleet of trucks simply gets rerouted. This is the foundation of high availability systems. It's why services like your bank or your favorite social media app can survive a major outage in one data center. They always have a hot backup ready to take over. This principle applies to backups as well. A backup is essentially a snapshot, a copy of your warehouse at a specific point in time. But as we've seen, a simple copy gets outdated quickly. Modern disaster recovery strategies are all about continuous synchronization, ensuring your backup is always just moments behind your live system. Understanding this logistics metaphor, the warehouses, the trucks, the dual writes, the road signs gives you a powerful mental model for thinking about some of the most complex challenges in software engineering. It's not about magic. It's about a well-defined, step-by-step process designed to minimize risk and eliminate downtime. The next time you hear about a major service migrating its infrastructure, you'll know exactly the kind of intricate dance they're performing behind the scenes. We've covered a lot today, from the pains of downtime to the elegant solution of zero downtime migration. It's a fascinating topic that touches on the core principles of building robust, resilient systems. I hope this warehouse analogy was helpful for you. If you have any questions or have your own migration war stories to share, please drop them in the comments below. I love reading them. Thanks so much for watching. If you found this video insightful, please give it a thumbs up and consider subscribing for more deep dives into the world of technology. I'll see you in the next one.